Good time of the day to everyone. Let us wait another 2 minutes. We are expecting some more people to join, and we will continue with our discussion. Could you please let us know if you could see us well and hear us well? In the comments, you can write if everything is fine. Excellent. Thank you. Thank you so much. Okay, let us start our webinar today. Today we will talk about on how to reduce total equipment downtime from 30 to 50%. We will talk about proven strategies and best practices. How do we apply these strategies in our daily operations? Our speaker today will be Oleksandr Ochkassov. Oleksandr has his PhD in technical sciences. He also has several scientific publications, and his area of expertise is the development of methods and tools for technical diagnostics of locomotives and their components. He is also involved in the activities for improvement of fleet management methods for technical equipment, modeling of locomotive components and systems. Also, he is the expert in methods for analyzing the reliability of locomotives. And Oleksandr also applies machine learning and big data technologies for analyzing diagnostic information and improvement of rolling stock maintenance systems based on diagnostic results. He is also involved in the development of methods and tools for technical diagnostics of locomotives and their components. So, Oleksandr, we are glad you are able to join us today as the main speaker. Please go ahead with your presentation.
Thank you, Oleksandr, for introduction. Thank you, everybody, for joining us. I'm sure our webinar will be useful for all of us, and as a result, we will be able to find out some new insight, how it's possible to reduce downtimes, and how you will be able to make your maintenance system more efficiently, and how you will be able to save on money in maintenance. I hope everybody listen me clear. Please type in the chat, is everything okay? And in this case, let's get started. Please, next slide. Could you change the slide? First of all, I would like to discuss why equipment downtimes is so important. Every unplanned means any unplanned downtimes means less production and financial risk for the company. Experts say that companies in almost all industries lost between 5 and 20% of their production capacity because of unplanned downtimes. But downtimes is not only about production numbers. Downtime has many hidden costs. It can damage customer trust, delay deliveries, or even lead to loss of the contract. In industries where safety is critical, every minute of failure also increases risk for people, for environment, and for the company reputation. So downtimes is not only technical problem. It is a business problem with a strong effect of profit and competitiveness. To understand the scale, let's take the oil refining industry as an example. Here the numbers are very high. A single hour of downtime can cost between $100,000 and $1 million, depending on the complexity of equipment. For large refineries, one day without production can mean more than $1 million in direct losses. Across the whole industry, in the United States, unplanned downtime costs between $10 and $20 billion each year. This shows us how critical equipment reliability is. Okay, there was number from the oil and refining industry. Show us how serious problem is. But I would like to ask you, in your company, what do you mean? What is the most common cause of downtime? Please type in the chat if you think it's equipment failures. If you think it's software and control system issues, please type 2 or 3 if it is human errors. Okay, maybe some other else. Please make your answer in the chat. Okay, thank you for your answers. Let's continue. First of all, studies show that the most incident of downtime can be prevented. How? With better monitoring, improved system integration, and proper staff training. Many failures do not have to happen. Still, according to the studies, about 52% of all unplanned downtimes come from equipment failures. This means wearing, fatigue of material, or other physical problems. Another 29% comes from software and control system issues. It's things like automatization error or communication faults. And finally, around 90% is connected with human errors. For example, wrong action or missed signal. What is important here is that all these problems can be reduced. For example, equipment failures can be reduced with sensors and analytics. Software issues can be managed with better integration and better testing. And human errors can be reduced with training and decision support tools. Okay, now we know the main reason why downtime happens. Equipment, software, and people. But there is one more important question. Do failures happen suddenly? Or do they usually give us some signals in advance? From real experience, many failures do not appear out of nowhere. We often see small signs first. Unusual vibration, higher temperature, or slower response from the systems. These early signals are exactly what we want to catch before breakdown happens. This slide shows us typical failure patterns. A lot of us know these patterns and how equipment degrades over the time. This pattern shows us, but this model are useful only in general guide, like a general guide. They help us think about repairs might be needed and how to avoid unexpected stops. However, these patterns are not universal. For example, pattern A is not suitable for maintenance planning. It is mixed different behaviors and give us little value. Pattern B and C. The key moment of this pattern is to detect the moment when the equipment reach some critical levels of degradation limit. And maintenance just have to act in time to prevent some failures in the future. The main message is simple. This pattern exists, but failure development is individual for each machine, for each type of machines, and for each components. In this case, modern maintenance should move from simple methods like this to real data and actual condition of the equipment. Now we just look at how failures usually develop over time. We see that most equipment doesn't fail instantly. There are signals, patterns, and early signs. Natural question is the next. If we know these patterns, how would we organize maintenance? For many years, companies use traditional approaches. Schedule repair, manual inspection, and fixed service intervals. But there is a problem. These methods are not adapted for real condition of equipment. Why? First of all, traditional methods are based on schedule and manual work. Companies usually plan repairs and fixed time intervals, make visual inspections during shutdowns, and replace component after a certain number of hours or cycles. Yes, this reduces the risk of total failure. But it has many disadvantages. First of all, it often means replacing parts that are still in a good condition. And as a result, you're spending too much on unnecessary maintenance. And still having to stop production for planned repairs. In other words, it's not flexible. However, this approach is suitable for maintenance staff. Which approaches are considered like traditional? First of all, it's a reactive approaches. And during your registration in webinar, we see how it was important for you. Reactive approach. In this case, the maintenance team waits until failure happens. They are doing nothing. Their task is only to fix the failure, and it is consequences and consequences of this failure. Next step of evolution of maintenance, preventive approach. Here is the maintenance teams follow a fixed list of working period, fixed list of service operation, and fixed working periods. We have already discussed the advantages and disadvantages of this approach in the previous slides. However, now I want to ask you next question. What do you think are advantages and disadvantages of reactive approach? Is it really bad or it is good? In which situation could it still make sense to use reactive approach? Please write your ideas in the chat, and we will discuss your answer during Q&A session. And now we will continue. On this picture, we ask an important question. Why traditional approaches no longer work? The first problem is that many old methods depend on collecting data about critical failures, the most important questions. But in real life, no company wants to let their machines run until their damage happened, just to collect statistics. Nobody wants failure because he wants to collect statistics. Every critical failure reduces the service life of the equipment and bring high repair cost. No businesses would accept that. The second problem is the lack of reliable data. To build strong maintenance models, we would need a large number of repeated failures. But serious failures happen rarely. And this is good for operation, yes. But it is bad for statistics. We don't have enough data. As a result, companies simply do not have enough information to plan effective maintenance with traditional tools. Finally, the world of businesses today is very competitive. We cannot afford long experiments or downtime just to gather data. If we continue to use only traditional maintenance, we risk losing both money and market position. Because of this, companies need to move from old methods of maintenance to a new data-driven strategies. New data-driven strategies based on sensors, AI, predictive analytics. With this approach, we can monitor equipment in real time and make decisions without waiting for failures to happen. On this slide, we can see what the next generation maintenance really means and what result it can bring. First of all, let's look at the key principles of Industry 4.0. The first principle is real-time monitoring of equipment condition. This means we no longer wait for periodical inspection, but we always know how the machine is working. It's a first step. The second principle is the use of IoT and sensor technologies. Sensors continuously collect data, temperature, vibration, pressure, or any other important parameter for some equipment. The third principle is the use of big data and AI-driven analytics. In this case, we use artificial intelligence. We can analyze huge volumes of information and detect early signs of failures before they become serious problems. As I told you before, the most important thing is catch early sign. And the fourth principle for Industry 4.0 is automated maintenance management through the digital platforms. It makes planning and schedule faster, more precision, and less depends on manual work. As we discussed, maintenance has changed a lot over the year. And today we focus on advanced strategies. What does it mean, advanced strategies? It includes predictive and proactive maintenance. What does it mean, predictive maintenance? We fix equipment before it breaks. In this approach, we're using sensors, data, AI to plan repairs at the right moment. Example, predictive maintenance means we see the problem. For example, a sensor shows that a bearing is starting to vibrate. We know it will fail soon. So we plan some maintenance and replace this bearing. Okay, it's good approach. However, we have a next step, proactive maintenance. We ask, why bearing often fail? Maybe it's because of dust get inside, or we have a bad quality of cooling. In this case, instead of only replacing bearing, we start to analyze and we change the decision or we add some protection for bearing. In this way, with proactive maintenance, the same problem will not come back in the future. These strategies make maintenance smarter, safer, and more efficient. Okay, let's summarize how Industry 4.0 can be implemented step by step. First of all, we start with the data, installing sensors and collect information on key parameters like temperature, vibration, and so on. Next step, we create digital view of equipment health with real-time monitoring. Here we can add artificial intelligence to detect anomalies and predict failures. And finally, we integrate all this tool into daily maintenance operation with predictive strategies and automated planning. It was the first part of our webinar. If you have any question, please ask question in the chat, and we will answer for your question during Q&A session. Now I would like you to look through some practical example and how all this theory can be implemented in practice. I guess a lot of us see such picture. But let's be honest, many companies still rely on dispatcher to monitor their equipment. We have a lot of pictures, but human can track only 5 to 9 parameters at once. Only 5 or 9, or from 5 to 9 parameters. And even the most focused person can concentrate for about 90 minutes. 5 parameters during 90 minutes. After that, mistakes happen. Because all of us have some limits of concentration. In this case, AI starts to help. And now I want to show you how this idea works in practice with our solution and Maly. Our idea is simple. Prevent instead of repair. Maly use artificial intelligence to detect early signs of equipment failures. It's like a small assistant. She never sleeps, constantly monitoring your machines and alerting your maintenance staff before problems happen. Maly analyzes data from sensors and keep improving its ability to detect problems earlier than it happened. We create such decision, and it's easy to work with Maly. First of all, our first step, we start by selecting equipment. Maly knows a lot of libraries. She knows a lot of methods at equipment. By first step, we start selecting the equipment. It can be pump, engine, or any other kind of machine. Maly can monitor different types of assets and automatically adopts his methodology for each type of machine. when we create anomaly, we gives to her all our knowledges. Anomaly combines several analytical methods, statistical thresholds, and trend analysis. Together, they detect both sudden spikes of parameters and slow changes parameter, which show us equipment behavior. Next stage, when you choose some equipment, we start to learn. As any AI system, anomaly should be learned. First of all, we have to show anomaly which operation mode of equipment is good. In this case, anomaly learns that how normal operation mode looks and how your machine works in normal operation mode. She analyzes some specific patterns, and it helps her to avoid some false alarms later. In the slide, you can see in the top, in the top, like normal mode operation, and in the bottom of picture, you can see how anomaly detects some abnormal situation in your equipment. When some abnormal behavior appears, anomaly immediately send an invitation, send some message through the chat or another kind of communication. As a result, you can see when and where the issue started and how it is serious. Anomaly, as I told you before, working 24/7, and she monitor your equipment during all this period. All detected anomalies are shown in a simple and ranked list. Engineers can focus to the most critical problems first and plan maintenance effectively according to anomaly results. Next step of anomaly learning is confirming of reject each others. Engineers can confirm or reject each others and add short comments. If we have some others, engineer add comments, and in the future, anomaly will analyze this feedback, and it helps her to improve detection abnormal situation in the future. In this case, we will be able to detect anomalies, and anomaly will send information. For example, this equipment has some abnormal behavior, and according to my idea, it can be, for example, lack of oil. Anomaly learn and improve its detection accuracy over the time. Okay, and how we can use anomaly in a practical way, and how it help us to manage an equipment maintenance. This slide show how anomaly may help manage equipment maintenance. Every machine goes through different stage of operation, from stable works, which shown in green color, to the first sign of failure, and finally to breakdown. With anomaly, we start at the very beginning. First, anomaly monitor technical condition. Then it detects anomalies and classifies them. Next, it predicts remaining resources, remaining useful life, and make risk assessment. The idea is simple. The earlier we detect a problem, the cheaper is to fix it. If you wait too long, one failure can be cause of other, and shorten the life of whole machine. There is a reason why preventing failure early is always much cheaper than repairing after breakdowns, especially for critical equipment. There is another one practical example. For example, bearing was replaced after 800 hours of work. But in reality, it could have continued for about 10% longer. That means we lost part of useful resource and create unnecessary cost. This is a common situation. If we replace something too early, we waste money. If we replace something too late, we risk failure and expensive repairs. It shows us why we need accurate, up-to-date information about the real condition of equipment. With Anomaly, we can make the right decision at the right moment. Not too early and not too late. Sorry. There is some example of successful implementation of Anomaly. Anomaly has experience work in metallurgical industry. For example, in 2023, their equipment had, we implement Anomaly in some metallurgical factory. In 2023, their equipment had 180 hours of downtimes. It cost $1.8 million. After implementing Anomaly, downtime dropped by 25%, saving them $430,000 in 2024. Did I already tell you Anomaly is smart enough? Another business case of agricultural industry. We have implemented Anomaly on a technical production line. This line product sugar. And Anomaly analyzed 85 parameters from this production line and detect 187 abnormal situations. As a result, we predict 5 potential failures in advance. It turned out of the 5% of time the production line was operating in unstable condition and nobody knew about this until Anomaly showed them. That's all. From my side, I suppose if we have any question, we will discuss this question in our Q&A session.
Thank you so much, Oleksandr, for your report. Yes, we do have questions from the comments, right? And first one comes from Maxim. The question is proactive maintenance suitable for any company, industry, asset, whatever?
Thank you for the question. Yes, predictive maintenance is suitable for any companies and industry. However, we should understand proactive maintenance. It's a next step, and it needs some basement. First of all, when we implement proactive maintenance, we should have clear information about your assets, and we should be able to analyze why some failures are repeated, why these failures repeat at the same time in the same condition for equipment. In this case, we should first of all organize collecting of data. We should launch some enterprise asset management system in your enterprises, and this help you to collect data from the equipment. Maybe next question.
Right. Another question also, like, can anomaly could be used for any type of asset, like mechanical, electrical, electronics, or whatever?
Yes, thank you for the question. We create anomaly for any kind of industries, and to be honest, there are many equipment, many assets in the different industries is the same. For example, pump. It has the same like task in maybe in oil refining industry, in railway transport, or in some sugar production. In this case, Anomaly has a built library with more than 100 presets, and for any type of equipment, you should only choose presets, choose a kind of equipment, and Anomaly will know which methods is more appropriate for this kind of assets. And maybe, Alexey, we should discuss this result of our survey.
Yeah, we have two more questions, and then we will do the survey results. Right. The next question would be for metallurgical industry, right? What type of assets were used when we implemented anomaly with them? Types of equipment. I assume Maxim means types of equipment that we used in the project.
During this project, it was a lot of sensors from a different type of equipment, and it was it's difficult to say in English for me, sorry. It was special equipment for metal production. It was line, special technological line where metal steel produced. And however, as I told you before, if we have some line, it has electrical motors. It has some compressor, and so on. In this case, for anomaly, it's not so important to catch difference between equipment. Is it engine or is it pump? Because for engine, she knows some methods for analyze data. It's more important to catch some features which connected with these enterprises. In this case, we told, as usual, we need from 3 to 6 months for anomaly learning, for preparing for preparing knowledge base, for anomaly knowledge base, and during this period, anomaly will be adapted for some special condition of operation, especially for these enterprises or for this technological line.
Right. When any mistake is critical, right? Especially for metallurgy, if something happened with the leather, with the molten metal, it will be a disaster, and not only for the company, but for the, let us say, environment, the ecosystem around as well. Right. And same question about the agricultural industry, and I assume that the situation is the same, right?
Yes,
they also have different types of equipment and different sensors, and it depends on the type of connection to the equipment that we use to get the data. the data just coming into the system for the analysis, and Maly just analyzes the data and detects the anomalies, non-typical behavior of equipment.
Yes.
And notifies the respective responsible people. There is something wrong with the equipment. So after that, the engineering forces, like the engineers, the maintenance technicians, they look more into detail about on the cases happening. We also have sorry, Alexander, you wanted to say something?
No, I totally agree with you. Thank you for your answers.
Yeah, we also have different other questions from Anna. Anna asks, what are the main barriers companies face when moving from traditional to reactive maintenance and to AI-driven predictive systems?
It's a good question. Thank you. First of all, the main barriers, it's lack of information and not transparent maintenance system. According to our experience, when we came to some enterprises, sometimes things look terrible. They use a lot of paper. Some of them use Excel tables or something else. They type some information this bearing was replaced, when this bearing was replaced, why it was replaced, but nobody has time to analyze this data. They don't know when they will need to buy next bearing for replacing, and so on. Like the biggest trouble is lack of transparent system, often for enterprise asset management. And in this case, we propose for a client to start from the first step to implement some enterprise asset management system. For example, it's maybe our SmartEAM system. Each has 50 different tools, and it helps to move enterprises step by step from reactive and traditional maintenance to predictive maintenance. We help to launch scheduling collecting of data. We help to collect data about technological state. We run some process. It's like a digital transformation for maintenance business, for maintenance. As a result, when we collect a lot of, not a lot, when we collect data and launch such transparent maintenance system, we have a basement for next step, for predictive maintenance. And sometimes we have a such question when we discuss anomaly. Our equipment doesn't have sensors. What we should do?
Right.
In this case, of course, we should think about economics, about profit and profitability. If you have some equipment which doesn't have sensors, and there is no critical equipment, it doesn't impact on your enterprise's productivity at all. It's enough to launch, for example, asset management system and start to collect data through handle equipment. With such handle equipment, your staff will be able to measure temperature, vibration, and some other technical parameters. However, all this information should be inputted on inside the information system, because a lot of companies check this data like checklist, but they are doing nothing with this information. It's a wasting of money. It's a wasting of time. When information, this data inputted into SmartEAM system, this system use special algorithm, special methodology for forecasting, and as a result, you will know lack residual resources for your equipment. You will be able to plan your cost, how many costs you will be need in a future period for your maintenance systems. In this case, like to sum up, the biggest barrier it's lack of basement. What does it mean, basement? It's a data which includes technical equipment state, which includes information which kind of maintenance was done in a previous period. Maybe it was a little bit more, sorry.
Yeah, with regard to that, we also have another question from Anna, like about the return of investments. Like the question is like how long will it take, until you will see the economical benefit of implementing predictive maintenance solution like Maly?
Anna asked us really good questions. I would like to ask the same question. Are you able to calculate profit from fireman? Yes, of course. We should think about the profit. When I talked you before, when we implement anomaly in a sugar production line, it's a special technology, and enterprise has a really short period of time when they are able to produce sugar. For them, every minute of downtime, it means a lot of losses. And the same situation in metallurgical industry. According to our experience, from after first 6 months, you will have AI system which will help you to avoid unexpected downtimes. In this case, 6 months from the first 6 months of operation anomaly, you will be able to see the profit.
Right. And another question from Maxim as well. The question if I decide to implement anomaly in my company, right? Let's say for single equipment, how much time it would take to launch the solution?
Good question. Thank you, Maxim. If your equipment has a sensors, and it's, for example, equipment with less than 20 parameters, it takes 3 months, as usual. If you don't have a sensors, we have a partner which are able to help you to set up some sensors. And after that, we will start. If we talk about 20 parameters which are controlled by anomaly, as usual, it takes 3 months.
Absolutely. This is probably it with the questions. Shall we come back to the survey results?
Yes, it's possible. Let's discuss the survey result. First of all, I would like to say thank you everybody who take part in this survey. According to our analysis, to our point of view, why we got such big point for for the two first question. I suppose it's because of lack of data, no clear KPI and limited visibility of equipment conditions. All these issues can be resolved by implementing modern EAM system, as I told you before. Next level, overspending on spare parts and the same kind of questions. Why we have overspending money? It's maybe two reasons. First of all, it's a bad planning, and next it means bad technical state of your equipment, and maybe you are not was not be able to prevent some failures, and as a result you have a huge consequence of this failure. In this case, I'm sure we should implement enterprise asset management system like a first step, and the next step we should be ready to move from preventive maintenance to predictive maintenance. One more moment, Alexei. I would like to clarify last options. Low efficiency of predictive maintenance, too many unnecessary tasks.
You mean preventive maintenance?
Yes, preventive, sorry. It was unexpected for me, such result. And why? Because when somebody asked me, we spent a lot of money to maintenance, I would like to ask, are you sure you are doing only necessary task? Maybe, as I showed you before, you replace some spare parts in advance, but it is able to work, for example, next 6 months without any trouble, but you replace it. In this case, one of the ways to save your money, it's a knowledge about equipment technical state, and you will have this knowledge by AI driven approaches and by collecting data from another maybe easiest way with the handle diagnostic tools. Thank you. I am ready to ask for another question if it is.
Yeah, actually, upon registration to webinar, our participants also had questions to us. I assume let us go one by one, right?
Mm-hmm.
First one is, what tools or methods have you found most effective for monitoring assets?
Yes, thank you for this question. I have read this question before the webinar, and I was going to explain the answers during webinar. In my point of view, the most effective way is data-driven approach, and it can base on data which collected from IoT, and it can based on data which we collect during predictive maintenance. But the most effective way, in my point of view, is using AI for analyze result of monitoring equipment technological state.
Absolutely. Well, next question, please. Next question is, how can companies reduce maintenance costs and make sure it's well integrated with operations?
When we want to reduce maintenance cost, and how it's possible? First of all, reducing maintenance costs will achieved through real planning. How to explain? Engineer wants to have a lot of spare parts, because for his KPI, then less downtime he has, then more higher is his KPI. But sometimes nobody think how much does it cost, because for engineers, for maintenance staff, it's more calm to replace something during maybe 100 hours of operation. In this case, company can reduce maintenance based on modern enterprise asset management system, which analyze data, as I told you before, about technological state, about maintenance, and how much spare part were installed in a previous period. For example, we have some type of bearing. 2 previous year we used 3 of this bearing, and according to our experience, it's enough to have, for example, one of them like spare part, which be useful in unpredictable downtimes. In this case, we can analyze amount of spare part, and this amount of spare part should based on according to the real monitoring of technical state and according to the previous history of using spare part.
Right. Next question, please. What's the most effective way to plan and control costs in maintenance and operations?
I suppose the most effective way, it's a way which based on data, on real data. The most important thing, real data. Because if you don't have real data, you have only somebody's knowledge, somebody's experience. This knowledge and this experience, of course, it's good, it's important for your factory, but lack of, for example, business analytics, lack of tools which gives you insight, lack of tools which shows you history of maintenance. It can be a reason why you spend a lot of money for maintenance. In this case, the most effective way, in my point of view, is implementing enterprise asset management system, and you should launch such system without paper. It can be totally automated system without paper, without handle input information. In this case, you will be able to save money.
Absolutely. Do we have any other questions? Is there a next slide? Oh, that was the last question. So hopefully, we hope that this conversation today was very useful for the audience and interesting and useful. You got interesting and useful information from us, right? Please write in comments. If it is yes, please write yes, or give us a plus sign or some sign or whatever. So after this webinar, right, if you have any questions, please do not hesitate to contact us, and we will go one by one with your particular case. We will propose this. I'm sure we will propose the solution for you. And also, if you would like to start implementing this kind of approach at your company, we could also help you to choose the equipment to start with. This is basically all from us. Oleksandr, do you have something to tell also to the audience?
I would like to say thank you for joining us, and we are waiting for you in a future cooperation.
Excellent. Thank you so much. Hopefully, we will see you again. Thank you all,
Thank you.
and
Thank
all the best.